Good morning. Back live for the day. The whole day. I'm trying to think what I want to do from here, honestly. Maybe I should provide a little bit of context. Yeah, I think I'll take the first little bit of today and just sort of talk through some of my thoughts on what I've been doing for the last bit and where we can go from here. So I just ran this experiment, like literally in the last hour. It's not entirely new. It is a fair bit more stable, though, than what I had before. And what this is doing online RL, but keeping just a tiny little bit of off-policy data around. Tiny little replay buffer. And the thing with this task is the first chunk of this problem is a really sparse exploration problem. And it takes 5 billion steps for it to learn anything normally. And this is like a pretty aggressively optimized benchmark as well. So there's just a little bit of off-policy data, which is going to end up being like the best trajectory segments. You get this massive, massive improvement. Hey, Tim. Now, this is going to take absolutely forever to run, and I don't know if this actually gets us to a better place or if it just learns faster. But I suppose we have a couple ideas to look at. So option one here, right, is we kind of just assume, whoops, why is my mic peaking? This better? Yeah. So option one here is we kind of just assume that we're going to be able to not play by the rules and use off-pol data with on-pol RL. Option two is we go heavily into world models. Yesterday, linked a thing, which I think I saw the thing that you linked. It seemed like they had, correct me if I'm wrong, don't they have, isn't this supposed to be for like explicitly mixed expert data? And with online RL, it's not just like, I pretty much would like you to be able to use whatever data. And what they do is they constrain, they do like they add a constraint that you stay close to the actions from the actual offline data, I think. Yeah. But like, I'm not, so giving it expert data is one thing. That's like a problem. I kind of was using that as a motivating example of like where a lot of algorithms fail. In my mind, you should be able to have an algorithm that can do sample reuse, that if you give it a ton of data and like not very much compute will do as well as standard on-pol RL, and if you give it a ton of compute and not much data, it will do like as well as world models, but then smooth in between. The big problem right now in my mind is that there's this big compute gap where like you either use a ton of additional compute to have more sample efficiency, or you use a ton of data and get compute efficiency, and there's no reasonable midpoints. I can't see why it's so hard. So the reason that this is hard, Tim, is that if you look at the off-pol methods, they do like 200-fold sample reuse oftentimes, right? They do like a huge amount of sample reuse. And then the on-pol methods are like 0 or like 1x sample reuse, maybe 4x sample reuse. There's no like clear progression where you can go to 8x to 16x. Like, it just doesn't work. Why do you need so much? Well, what you would like to have, right, is you'd like to have a method where you can spend more compute to learn more out of limited data. So, I mean, here's the motivation, right? Show you. I don't know if this is still soda. Okay, so this is 100,000 frames of Atari. Like 2 hours of data. Very tiny amount of data, right? First screen of Breakout. Solves Pong. This is like better than human level sample efficiency. Well, I'm trying to figure out what to do at the moment more than anything, Tim. They do search right, but do you see the point? The point is, and it's not search on the env. It's all learned. It's a learned model. So they're spending more compute to get like near human level, well, actually like human level sample efficiency. Right, but do you see the problem? Like, I can't take this method and give it as much data as I give PufferLib and like less compute and have it still work. You either have a ton of compute and you get good sample efficiency, or you have a ton of data and you get good compute efficiency, but there's not really anything in between. It's the structure of the algorithms. Like, as soon as you train a world model, like, there's a fixed cost, like, there's a big cost to training a world model. And then if you look at, like, off policy, where you're not training a world model, that also can improve sample efficiency, but the algorithms are fundamentally weaker to the point that you'd need to spend more compute to get them to parity in performance, and then if you spend even more compute, then they get better. Problem is, this does not enable... This data reuse thing is cool, but it's a really weak version of it, honestly. I mean, pretty much what this result just shows you is, like, yeah, you need to be able to reuse samples. Okay, I guess here's what we can look at this graph as, right? Independent of the method that I used to do this, this says, and this is not even using any more compute, by the way. This is literally compute matched. So this says, if you can reuse samples, especially on like hard environments, right? There's a huge gap in what you can do if you can reuse samples. This is like very strong motivation for sample reuse. But the specific form of sample use I have here is very weak. This is like a very weak form of it. Actually, you know what? How much compute does Dreamer spend on its world model? Wait, maybe that's a good thing to look at. The model's enabling search. Yeah. Well, I guess then the question is how... You see the problem that, like, here, look. If I do, let me get this right. So this is Puffer. And then this is... And then this is like... And then this is probably like... You know... This is like Puffer if I optimized for sample efficiency. I could get it to here. And then this is dead space. There's like nothing in here. Does world model take so much? I don't think so. That's the problem. Let's look at it though. Why worry about compute instead of wall clock? So, I mean, I get this with clients all the time. The difference between these two things is if you hand me a slow simulator right now with Puffer, what I have to do is I have to make your simulator fast, and then I apply Puffer, which works very well for a lot of problems. But there's some problems that I can't make your simulator fast enough for. And basically, there's no way for me to just take your problem, spin up 1,000 GPUs and solve it for you right now. PPO is very compute efficient. Well, I see what you mean, yeah. Base PPO is not. Large batch PPO is, if you do it well. Like Puffer's implementation is. The thing, though, is it's a lot easier to make the world model stuff computationally efficient. Like, you have to really mess up the engineering to make this super slow. Actually, they did give us this, didn't they? I mean, the replay ratios are not even huge on this. It's just the models that are. Like, actually here you have 1. Interesting, it's a replay ratio of 1. Actually, that's very interesting, isn't it? You can't use off-policy data with PPO. Yeah, I understand why you can't do it in theory. Counterpoint. Counterpoint. Yeah, so I've tried something exactly like that, Carlos. Your value function gets stale. Because you don't have a way to train the value function if you just do behavioral cloning. I've tried like several different versions of that, actually. Why is this thing so bloody good on paper and then it just sucks when you try to do anything like this? I mean, I guess we aren't doing pixel reconstruction. What if the actor and the critic share the same parameters? Then it's even worse because not only is the critic getting stale, but you don't even have like any reasonable loss to prevent the value from like drifting completely. How did you do this run? Yeah, so I just kept around I kept around like a very small, like literally like a, was it like an eighth of a batch or something, just a very small amount of high advantage trajectory segments, and I just train on those. Like I keep those in the training buffer for sampling. So literally just keeping around a very small amount of data. Yes, you do. You just do it anyways, and you only use a very small amount of replay data. Policy exploration, because there's one. It means that you have data that's in a replay buffer that's like very stale. So you're not only training on data that is from like roughly the current policy. They have 100. I thought they had like a 1 mil. Your world model approach look if you tried Pong with full RGB frame buffer instead of 8 obs. Why would me having a very low ob space, like, that should make it easier, shouldn't it? It should be easier to learn a good world model, no? I wouldn't see how. It's difficult as well to evaluate because, like, basically once you step outside of the high data regime of Puffer, like, all your experiments start taking days. And I'm not doing research where my experiments take days. That's just a complete waste of life. When it says higher replay ratios, hmm. To join the Discord. Discord GG/Puffer. RL is hard. I guess we should just, like, go to and bootstrap a squad versus squad drone fight in PyBullet. Probably your problem is that the env is slow, would be my guess if you were using PyBullet. We have drone EMs and, like, fighter EMs where they run millions of steps per second. It's a lot easier to do stuff there. Like, not even particularly difficult to get, like, that type of stuff to work. The env is just fast. I mean, I think I have to just go back to the... I think I just have to go back to the Dreamer crap, right? I mean... This paper drives me insane. This paper just actually drives me insane. I wonder if it's time to start from their code. It's in fricking Jax. Do I really want to do that? Value loss is MSC. What if you reevaluate and recompute the advantage? The, so the whole point of training the advantage, right? The entire value is that the rewards come from the policy. Like, it's actually a way stronger on policy assumption for training the value function than for training the policy. Like, if you actually kind of squint at the math for policy gradients, you don't really need the data to come from the policy at all. If you look at the value function, though, the value function update, you absolutely need it to come from the policy. Rewards are a function of the state. Rewards are not so... a function of the state. But you care about transition, like transition to reward, not state to reward, right? I guess I could try... Okay, I mean, at least this code is not batshit. And it has close repro. MIT licensed. Is this the best one? PO, save good data, behavioral cloning, refresh value, repeat. You can recompute the advantage, and I do recompute the advantage. I don't think you can keep training the value function, though, because the whole point of the RL is that it takes the policy off of the current reward segment data. You're not doing off policy, really, Carlos? It depends what you mean by save good data and how long you keep it around. I'm gonna try something with this repo. Honestly, let me just fork it. I kind of want to just bind this to some PufferLibs and see if it does anything. really care about my Joko. Maybe. Maybe. Such a pain. I don't understand how this is the state of packaging. So ass. Should I just make an M specifically for this? Why is it one environment? Oh, I know why. I think we just start going through this and simplifying. I don't really know what else we can do for this. Other than, we'll go find whatever the command is we're going to want to run. Trying to catch up with talking to a friend. I don't know why we open certain sampling is good. We suggested something like, I think adjacent to advantage weighted aggression. Yeah. So the sketchy thing with advantage weighted regression is, do you notice that the paper does like 200-fold sample reuse? Like 200-fold sample reuse for Like, literally all of Dreamer is less sample reuse than that. Most of it is. I suppose I didn't try the weighted exponential for advantage. That's about the only thing I didn't try. I want to do this for a bit, though. Hey, boxing. I'm working on stuff as usual. Yeah, I'm working off of I'm trying to get an existing Dreamer repo to run on Puffer just to see if it like magically breaks somehow. And if I can play with it a bit. Why is all research code so bad? Puffer just is not set up at all for this thing. Is this even used for... This is used, right? I think that I have to do... Hello. Welcome. Do you have a point, good sir? This code is just like I'm pretty much just trying to retrofit Puffer onto this mess. Yeah, it's such a mess. What? Yeah, teammates would be pretty easy to make. The problem is that there really aren't any memory M's in RL. Like, that's not even a pure memory env in RL, because everything in RL is, it's entangled with credit assignment as well, right? Hmm. I like that your enjoyable places are Paris or in a forest. Have you been to Paris? It's not that great. It's really nothing to write home about. I live there. It's funny. Yeah, there you go. I don't know. For whatever reason, a lot of Americans think like Europe is this magical place where everything is great. Food was good. I don't know. I honestly, it's not anywhere near the top of my list for even that. That should be biased. That's funny. Move this mic a little bit. I can't freaking see this monitor today. Oh, I know what happened, actually. The Americans got the bantering, then go to Europe. Yeah, that's pretty much it. I mean, Europe's if you're looking at cities, like most of Europe's cities are nicer. You get nice cities and like zero social mobility and opportunity. We do have real jobs here as well. Where do you think all the research is coming from? Okay, so this is running at least. Yeah, and 100K is like below entry level for like any half decent software in the US. So like there you go. Yeah, American suburbs are really nice and rural areas. Not public labs. No, at labs, like if you're working at a lab or like anything government, you're getting paid nothing. But like most of the jobs in the US, it's not public sector. Exactly. Mm-hmm. Yeah, I don't think I'm physically capable of taking like just taking a month off. I don't know. It would kind of be nice to work 5 days a week instead of six, but I get so much less done if I only work five. Looking at this paper. Wait, this is model based in model errors. This is ETH Zurich. Alright, I'll have to see this. Oh wait, is this the same Lucas I'm thinking of? I'm gonna have to read this later, though. I don't have the mental to, like... I've kind of, like, all mathed out myself. What about Lucas? It's probably a different Lucas. No, I'm thinking of Lucas Nestler. He's also in Zurich. Puffer dashboard has spoiled me. Yeah. Look, as soon as I figure out this research problem, I can actually optimize the crap out of everything and make Puffer way nicer. But this is just driving me insane. Did this thing just collapse itself? Oh no, it's just always been. Well, I guess I don't have the sample reuse cranked up. But still, I mean, so far this thing has spent 10 minutes of GPU time to sit here and do nothing. See you, Boxing. So literally even the reference implementation so far. I guess we'll let it run a little longer here, right? But like, kind of ridiculous. Let's see where this is even, let's see where this is training. Okay, that's starting to get real data, I suppose. In return. I'm pretty sure I set this up correctly. There are a couple quirks with Puffer you have to be careful of, but I think that it's correct. I don't know why the eval return is still so low. Where the heck is the actual code for this thing? Like, is it in the agent? Kind of. Oh yeah, the losses hang off. Okay. It should be Tim. Okay, now it's actually getting to the eval return. So you use 20 minutes or so of compute. Gonna be. Can I work with this from here? I guess I technically can work with this, right? Well, I guess it depends on if this actually solves. If this actually solves the task in, like, a reasonable number of steps, then at least, like, I can work with this. And I can just start deleting all the other crap out of this repo. Well, I probably do want to have at least one of the original tasks to make sure I don't break anything. And I'll just have to, like, actually understand this repo, right? It is odd that this is... Well, I mean, maybe it's not odd that it's, like, few 100,000 frames, then, because I don't have the same sample reuse ratio. So they literally use, like, 3 GPU hours on 100k frames of Atari, huh? It's nuts. Like, batshit crazy. The eval return crashed again, though. To be determined whether this is impressive. So confused as to how this works. Like, no code in here. All the compute's going into the world model pretty much already, I'm pretty sure. So I don't think so. I think basically all the compute's already going into that. Get rid of this bot. Here it is. Hmm. Thing doesn't seem to be solving yet, though, right? Bothers me. Yeah, it's like it's learned something, but it's not weird. Very weird. And then I actually don't know if this is even going to make sense without having image obs. No, this is our version of Pong. Hard to say, Tim. Yeah, I know, like, they have their own image obs as well. What do we do with this thing? Oh, take off? No idea. I'm just, like, not willing to accept that it's really this stupid. Still not working out of the box on my thing. Super tuned to images, maybe. This is, like, perverse, though, right? Yeah, this is perverse. How long this takes. What's the difference in model size? I mean, it needs to have this many parameters because it's doing image modeling, right? Maybe we can try. We'll go back to my version. What is the scaling with model size? See the model size scaling. It's like scales better with the replay than with the model size. Some of these. Actually, there's a better way of implementing this replay ratio thing, right? I think so. I guess the best thing that I've seen so far then, given that literally even this is not really working on this is not even working. even the reference. I think we go back to my implementation and we try to go from that angle. I mean, if this had just like insta worked, it would have been a different story. It's like, oh, okay, I'm dumb. I just implemented shit wrong. I mean, this is just like yet another piece of evidence that no, it's not just as good as it seems on paper, right? I'm also sick of staring and like waiting at this stupidly slow thing. I'm gonna use the restroom real quick. Time is it's 12. Make some coffee. I'm gonna go make some coffee. I'm gonna take a few minutes, and then I think we're gonna do from my section of the model-based stuff. At least for a little bit today. And then if that doesn't work, I really just don't know. I'm like not satisfied at all with having a very complicated, very janky algorithm that needs like 100x the wall clock time. But so obnoxious. It needs reconstruction gradients. So it needs reconstruction gradients. It's unclear whether or not those need to be image reconstruction gradients. Let me go make myself some coffee, folks. I'll be back. Yeah, and this is finished training, and look at that. Literally random perf. Shit algorithm. Okay. Did any of your world model toying stuff work? Go check one of the evals. Okay, this is not as crazy then. Don't get me wrong, it's good, right? Oh, actually, wait, let me see. Yeah, we'll let this experiment just do its thing. This is actually... It'll just depend on that. We'll have to let this whole thing just run. I mean, this is a crazy gap, right? PufferLib. Well, it's not the best for it, but it's like... it's either you use PufferLib or you're competent and you write your own thing, right? I guess CleanRL, you can hack a CleanRL script. That's like the other simple thing. I wouldn't like go use one of the big horrible libraries. Yanlakun says world models need to be energy based. Yanlakun's burned a lot of his credibility. At the very least, I'm no longer gonna just like pay attention just cause he says a thing. It's crazy to me that this like slow ass demo is still 200 times faster than the Dreamer code we just played with. — 2048 times 16. That's 32K. Maybe you just want the data to come in way slower, right? Like, let's say do 64 Ms. Moved Walker. Euler to F, RK4. How the hell did you implement it? RK short, like, both of those seem slow to me. Are you just doing a ton of iterations? Yeah, I think that if you need to do some balancing, right, to like actually see how much error there is with the different methods. My guess is you're going to be able to do larger steps or fewer steps or something in order to compensate. A quadruped sim should be at like millions. There's no way that I refuse to believe a quadruped sim has to be slow. There's no way it's 200 physics steps needed. No frickin' way. Go actually like evaluate the errors that are involved in your calcs and base the number of steps on that. Or it doesn't have to be a fixed number of steps, right? You can do like should be like a certain threshold cutoff. A lot of my job in RL is telling people writing sims who are like, no, it's very complicated sim, has to be very slow in order to be very accurate. It's just, nah, make it fast. I hear what you're saying, but can you just make it fast? This is probably There's no way you need to do this much, right? Like this. Even 1 and 1 should be fine here, right? There, that'll get us like some decent perf. Better. Episode length cannot possibly be 5. Mm-hmm. Okay, that's fine. You know, I'm not understanding this. You have a massive entropy coefficient and it's still 0. Why we do this, right? Okay. I mean, that's Pong doing something in a few 100k steps. I mean, this is kind of good enough to start automating a little bit, right? What's happened so far? We tried one of the like actual reference implementations for Dreamer and it sucked. So I went back to my own implementation and I got Pong to like start learning stuff pretty quick. There's a lot of instability and such, but I think that we can probably do something reasonable about this. And there you go. Okay. It would give me so much amusement if we just end up doing our own thing and winning. And not bad. 1 minute experiments is decent enough. We'll see how this does overall. That's funny. Amazing. Transferable learning across M's. I don't think that makes fundamental sense for a lot of these. All right. So this does give us gives us a different way to control the learning, right? This basically lets us edit the stream rate of our data. That's really good. I actually could probably come up with a decent algorithm out of this, you know? Like, data comes in at a fixed rate. You do online RL. You train your world model. if the world model errors below a certain threshold, then you do RL on the world model. It kind of depends if I can get something to be like reasonable out of this. Here, let's go pull up the latest, the sweep and such, right? I'm exhausted from this week. Holy. It's like getting more and more aggressive about freaking updates. Stupid Windows. Whiteboard the idea. It's not complicated enough to be worth whiteboarding. It's just like you could basically decide to only use the world model, like to only apply RL to the world model when the error is below a certain threshold or something. So you could just mix online RL. Now the thing is that the world model is usually pretty chunky, so like you're still gonna have the overhead of training the world model even if you're not using it, which really isn't great. Yeah. That bit's kind of tough. Okay, so I mean, this will do some experiments, right? What we can figure out in the meanwhile. So all I did was I basically just rate limited the data, right? So you get little batches of observations coming in. You do hardware efficient world model training and world model RL. I mean, realistically, this should mostly work. Still doing reconstruction loss on obs. Yes, Spencer, because the Z to Z loss, I think, is actually harder to learn. You're actually probably right, though, that I should probably see what that does. So I would like to actually not have to do obs reconstruction. It's really obnoxious for non-pixel ends. But I think that the obs reconstruction is easier to learn for the simple tasks to start with. So Spencer, I kind of just want to, if I can get something that's like decent enough here, and that's like more sample efficient than base puffer, and like the experiments run in a few minutes, then the key source of error in this whole approach is just the world model, right? So like if we can get the world model to just learn better with less data or faster or whatever, then this starts being better and better of an idea. It depends on the structure of the obs as well. Like think of Breakout, where each of those is like a specific brick. It's kind of a weird thing. Like very sparse changes. A lot of the image M's have like a much smoother change. I did actually get... So this is... I got two things, Spencer. I don't know if you've seen. So this is 1 million steps of Pong with very unoptimized hypers. So like you actually start to get some learning out of Pong in under 2 minutes and less than 1 million steps. And then the other thing I did, and this one's pretty cool. Do you see the Twitter post? We have at least what I would call good motivation for doing this. Look at this. That's Neural MMO 3. So, well, because you didn't understand because I didn't post the full details of it, right? I kind of just vague posted a thing. But let me show you. Okay, so here's Soda on... Where is it? So here's Soda on Neural MMO 3. And then this is what happens if you just ignore all reasoning and you just store like... I think it's like a quarter of a mini batch. No, an eighth of a mini batch of high advantage segments. So you basically have a very, very small replay buffer. So almost all the data is on Paul, but a little tiny bit of off Paul data without corrections. And you get this gigantic difference immediately without even retuning hypers or anything. This is 5 billion steps before Neural MMO starts to learn anything. Starts learning instantly. Not bad, right? Now, whether or not this this helps long term, I don't know. But like at the very least, this is a pretty solid, motivating use case. Because this is like the dumbest possible sample reuse, right? This is like the dumbest possible sample reuse, and it does this. If we could, I'd say, Jess, if we can get the world models to learn faster, then it makes a lot more sense to be using them more. My goal is like... My goal with all of this is very, very simple. I guess technically there's a separate thing of just like sample reuse for the sake of sample reuse, which is good, but my main goal with all of this is to just be able to spend more compute or spend more data, so turn the knob either way, and have one algorithm that smoothly does both of these regimes. That's the key. Is there actually any good stuff on world model architectures? Oh, actually, I have... I know Lewis, who is doing a world model startup, so let's just go ask him. The guy that wrote that poll. Wait, what poll? I think there's a way to predict how complex an environment would be. How complex the best metric we have of environment complexity is compute investment required to learn it, right? With an optimized model. See that plot with different sizes of the buffer? Yeah, so Carlos, if you make the buffer much bigger, it collapses. At least I didn't try that on neural MMO, but on simpler tasks, if you give it too much off-pol data, you collapse it. Lacuna would tell you JEPA. Is there a white paper on this? Yes, there is. Thank you. This is what I was looking for. A lot like you and what he talks about. Dreamer. I would hope not, kidding. Wait, I sound like Janiger or I sound like Yen LeCun? I think I'd take the Yen LeCun. God damn, that's a tough one. I think I'd take the Yen LeCun one, honestly. Yeah, so Danager's the dreamer guy, and there's a pretty big problem with the quality of the science in that paper. I mean, you wouldn't hear me say a damn word against any of it if I just had implemented stuff and it worked, or like if any of the previous studies I had done had like just worked, right? Does anybody know where the latents are in this paper? This like giant report. Manager? Yeah, please no. I will have to be committing seppuku. Insta demonetized if any of these platforms have auto translate. Jesus. I will not take that comparison, thank you. Work is about as far diametrically opposed as possible. I have really nice code that actually works and really shitty write-ups on everything. He has really crap code that doesn't work and really nice write-ups on everything. All right, I'm half exhausted here. Does anybody know where the latents are in this thing? Is it this? I don't know if I dare just type this into Grok. This is a position paper, though, right? Or is this the actual... I really just need to know, like, the latents. Like, the way that, like, latents are done well. I could go look at the original world model paper. Latents is figure 15. Thank you very much. This is not what I meant. So, Jess, I meant the actual, like, what is the mathematical representation of the latent? Is it like a multi-categorical? Is it Gaussian? Like, what are they actually doing as their, like, low dim representation? Oops. This is almost an RSSM as is. Okay, so this does both. Interesting. Yeah, so this is what I mean by the latents. So they do both here. I think this paper is missing... It's like missing good ablations, right? Yeah. Annoying. Okay, look at this. You see, we're making progress. So this will actually potentially get us a good starting point, and then we'll be able to do some architecture work, right? I mean, that's a million steps for up to, what is this, like 10 or whatever? 12 score on breakout. I mean, on Pong. The human searching, yeah. I mean, you see how little I use language models in my stuff. I basically use language models as a crutch for my bad math. And that's not because the language models are good, it's just because I'm really bad at it. I'm not under any impression that it's like, oh yeah, I don't even need to know any math because I can just ask the language model. It's just as stupid as the, like, I don't need to know how to code properly, ask a language model. So here it is, train VAE, and then train MDRNN. This is a little bit different though, because the world model, they train the world model first, right? Which doesn't work in general. This works on easy ends. I think, but Dreamer does them both jointly, right? Was it Dreamer v2 that introduced the categorical? The original paper does not have applications on hard environments. The original world model paper does not. Action conditioned. What? 311 is Atari. Oh, you mean for 3, yeah. If I do the rewards for reaching targets, moving towards them, I could add a controller to the M. Wait, use wanted to walk it around. If I do rewards for reaching targets, moving towards them. It's always a good idea to have your environments human playable. It's tough in the control case because you have to actually do like a classic control benchmark or some bullshit. I guess it depends, right? Because if you like, if the reward is just like face target, reach target, or whatever, you could basically map the last controls to just adjusting the target and then have the learn policy basically just carry it out. That would be cool. Yeah, that's actually a cool idea. Okay, so apparently this discrete latent matters a lot, as does KL balance. We can do the discrete latence thing. It's not that bad. We have a branch. Yeah, it's separate WM is the branch I'm currently working off of. Okay, so the KL balancing is cool. Latent space is a dense grid of patch embeddings. Okay, thank you, Jess. Yeah, that actually helps. So what that basically tells me is that the representation they use is specific to images, which is limiting, whereas the one that I'm looking at here is not. That's actually good to know. Let me see how different this thing actually is. I mean, the original is pretty simple, right? I can do this thing I can do. And then do you use the... Do you use the samples? Do you ever release code for this? Oh, this is funny. So, yeah. Uh... Okay, so this is the sample. You encode, you sample. All right, so you get a sample from the world model instead of an obs. Which this is actually... It's actually pretty tricky to come up with a good version of this because as soon as you start giving the actor latents, you have to start worrying about like the rate at which you're training each of these. And they totally punt on this problem as well because they have pre-trained VAE. Actually, does anybody know... Are there any good world model papers that don't rely on image gradients? Is that a thing? You can go back and look at like Mr. Q and what they did. Any continuous embedding vector. If it's any continuous embedding vector, you still have to be able to sample from it, right? Like the distribution matters. These guys do... These guys do separate reward and dynamics learning. Okay, but this is a very different algorithm. I guess, are there any world model paper that actually doesn't depend on the reconstruction loss? Whatever reason, Dreamer really, really depends on that reconstruction loss. I mean, if you include search, you can, right? I wonder why that is the case. I mean, I guess we can sort of work towards something like this. Because here they don't need to do reconstruction, right? Yeah, they don't need to do reconstruction. Yeah, the breakout scores in particular. I really don't trust that Dreamer just doesn't do crap on breakout. Weird. The yeah, the search component's very tough. Yeah, this thing is really slow, though. 2.7 hours per 100K. Hmm. I think it's just going to be let this tune a little bit. And then we're going to do just like some real quick ablations on the world model today. We'll try we'll try the latents. Try like a few different things. Try the categoricals as well. Funny that this run did better than anything else so far. I could just take this one as my my starting point, right? I'll go use the restroom, walk around a minute, and if there's nothing better, we'll just take that one. Be back. ones. You're not sampling. You can add filtering at the trajectory level. That's a quite different thing, though. Oh. Hang on, we just got a better one? Well, now I'm not gonna kill it instantly, right? I think if there's anything else I can try to figure out in the meantime. We sort of think about the compute loads a bit. I think it's likely that if we have a reconstruction loss, then the world model has to be a lot bigger than the actor, right? If we don't have a reconstruction loss, it probably doesn't need to be. At least Dreamer really needs the reconstruction loss, though. What do we think the odds are that it's fundamental versus just like a really poorly controlled baseline? I mean, they've seen it in every version of Dreamer is the thing. But it's probably just the same damn code repo. Like, touched up for 3 generations. I do kind of wonder if, like, if you actually went and retuned everything, right? Is it possible that, it just works without the image reconstruction? I've always liked the Mu0 style bit of it. I mean, the one thing is, like, okay, so there's, like, one practical annoyance here, right? Which is if you don't do reconstruction, you have to have a shared architecture. And, like, I'd really prefer to not have to have the world model and agent be shared. Well, because, like, you're just not going to be able to get nice reconstruction on a lot of ends. Major problem. And think, like, practically what this could end up looking like in Puffer. Not too far off of what we have now, right? Like, let's say we come up with reasonable enough world model architecture. We fix up the losses so that the world model trains way more stably. We retune hypers. Definitely possible. This is at least somewhat encouraging in that it's not... This is not a huge amount of compute, right? We are gonna have to deal with the reconstruction thing. Okay, I'm gonna just start copying parameters over from this blue one. And we're gonna see if anything's better by the time we're done with this. Yes, Jess, let me get this... Let me finish just copying params over, make sure this benchmark works, and I'll push it so you can get the latest. It is pretty cool to be doing research and having people, like, live in real time looking at stuff, you know? Ah, this entropy is really low. That's interesting. Okay, well, we've done a bunch of experiments, and we got what seems like a decent starting point. See if there's repros. See if this repros nicely or not. What do you mean? I'm just hoping these hypers actually repro. It'd be better. We test if the other one repros better. Curve seems less stable though. Start from here maybe. Change in state when an action is performed. Oh. Yes. Depending. Difference. Oh yeah, you need this trick, right? Interesting, this broke it. Okay. So we should see based on this then if the latent makes it better or not. Interesting. Very noisy. Did we crash it? We did. We crashed on the entropy. How's that make any sense? Nan's out on entropy. I mean, it was like, basically we were solving it, and then we nan out on entropy. Very common. Somehow. Entropy has crashed. You probably do need like some more explicit like max ent formulation. It's just so silly to me to be spending so much time fiddling with such like stupid toy trivial problems on like the paper's it's the best thing since sliced bread. Like you should be able to just sneeze in the general direction of this approach then and have it at least do something. It ends out. Okay, so what is even the explanation for that? Yeah, so that's but like that's a problem, right? Like for science to be that brittle is a huge issue. Right? Like Puffer is not that way. Like in Puffer, you actually just kind of do the thing. You mess with it a little and it just works. Like you don't have to poke at stuff a lot before it just works. Okay, so there's some hyperpram shenanigans here. There's some stability shenanigans, there's some hyperpram shenanigans, right? Yeah, it's a problem. I did a quick hyperparameter sweep, but like the problem is this data regime is just less robust than what we're used to doing with Puffer. So like you can get something where 1 in 3 runs will work, and then the sweep will find that, for instance. Let me play with it for a little bit. I'll get something to work. And then we'll see what we do from here. Yeah, it just crashes right at the end, which is really weird. Oh, you know why? We'll see if that makes the difference. Because otherwise it shouldn't be able to crash near the end of training. Like, the learning rates are all super low. Policy should basically just be stable. Nice, look at that. Alright, that's like... That's not bad. That's Pong close to solve in 1,000,000 steps. Let me commit this. Okay. Now we have... Let's just, do we feel lucky here? I think we're feeling lucky. What happens if we just do this? Might have been a bit much to hope for. A breakout is a much harder task. It's like very close to doing something, but just it ain't there. Longer training. Actual structure of the end. Longer training period. So it is actually right now, it's gathering 1,024 steps of data, and then it's doing 6 updates on 32K samples for the world model, and 1 update on 32K samples for RL. Kind of already doing this. We can go try the latents, though. The latents thing. If this makes sense. Or, I guess it's... We don't really have... latents. Pretty much you can just replace... Tricky. They just Yeah, they just spend a huge amount of compute is the problem, right? Like they'll literally spend 3 GPU hours on 100K samples. What am I working on? I'm trying a different, slightly different model setup real quick. I'm gonna try a self-consistency. Or like, what is it? I'm gonna try dynamics loss. Yeah, that's what it is. If he refreshes and gets to hang on, no winner more. Max score. I don't know what that means. Or more. I don't know what that means. Hang on, let me get this thing implemented. We'll see if this does anything. Single thing learned. Okay. Well, I might have been a little overeager on this. Checking one thing, hold on. Alright, so here's what we're gonna do about this nonsense. I think that all we have to do is we just roll this back a tiny little bit, right? Screw up here. Oh yeah, dummy. You got it. This should at least let us test, right? Yeah, okay. So if this doesn't repro the old thing, be an issue. I mean, there are a couple possible things I could have screwed up. I just want to see if having a predict next state loss does anything. I think I just messed it up, honestly. I totally just freaking messed it up. Unless, let me just see. Amex. If I comment this and it starts working, I doubt it. Huh. That's weird. Just having a dynamics loss breaks it. We'll see. Observations need to be more informative to build a MERD model. The observations to solve a policy. No. The observations are a full representation of the world, Spencer. This is the full information of the game. So I don't know if you saw it, Spencer. I got it to like almost solve. I got it to 18 reward on Pong in under 2 minutes with 1,000,000 samples. Like, I actually got that to do something. This, I think I've just broken. I almost want to just redo and try this again because I think I just screwed up the dynamics. You just make sure that adding a couple layers is not breaking it. So this is, like, this version of it's actually pretty stable. '19 score. Okay, so this should not make a difference. And then I can return. I'm not going to add it there for now. Okay, so clearly, right, this is the same as before. And then all I'm going to do is I'm going to add in the latent prediction, okay? Which is like this, with a detach as well. And I'm just going to do plus dynamic loss. We're going to see if this breaks it or not. Did I mess something up? Mhm. Alright, so this is the exact same thing as before, with additional dynamics loss, alright? So does having a dynamics loss break everything? Pretty pure test as well. Why don't we go take a look at our fun, other thing here? Well, this experiment totally fails. It's pretty nuts. So if I'm reading this correctly, though, then literally it should just be that commenting this allows it to work, right? Okay, yeah, dynamics loss breaks it. Cool. You have to do reconstruction, apparently. Like, incredibly stupid to me, right? Am I doing something fundamentally stupid with this? Like, this thing at least works, and works fast on Pong. If I had this working, like, on breakout in a couple minutes, then I'd be way more excited. We can try a few things, I guess. What happens if I do this? Why does it get faster? Right. Okay, so here we go back to our original horizon. If it can't roll forward, I almost don't understand how the heck there is even any error in the world model with the amount of data and, like, updates this thing is taking. Way worse. You know, Jess, I really don't know. And this has also just completely exhausted me this week. I'm trying to think if there's anything else I can do today that's like useful on this. At least we're not on frickin' cart pole, but like still. Okay. Um, if you get the world model right, this thing actually does scale with the compute nicely. Maybe that's what we try to do then. Yeah, that's a solve. Whether it's stable for the whole time or not. Of course, it's gonna give me 13 right at the end. Okay, let me then, hang on. Let me think of some stuff. Let's do, it's like 16 M's, all right? Like 2 and like this work. Okay, well, this is encouraging, right? You can actually get like some pretty crazy sample efficiency out of this stuff. Let's see if we can figure this. One. Is this stable or not? Hmm. Okay. Promising, right? Very promising. This is actually scaling with the compute nicely. Can get like a 200K benchmark. It'd be the same as just doing getting the data more slowly, right? So I would expect that there exist hypers that solve this in 100K, right? It's a good policy. Problem is that the final perf estimate you get is gonna not be good at all. I guess I didn't expect this to scale so well with the with compute. I didn't expect to just be able to drop the amount of data to almost nothing and have it still work. So even though it's a janky mess, it's like a mostly compute limited janky mess. It's not like really data limited at all. It's kind of weird. Yeah. Um this is sweepable. Yeah, breakout's still going to be a problem. I mean, at least, hey, at least this is progress because at least, at least I can see that even though the method is a mess, it does scale along the dimension that it is supposed to scale, right? Which was not true before. That's so weird how that actually does stuff. Oops. Like, can you literally... Is it going to be molasses? But breakout. Breakout working would be cool. You have to get like consistently above 8 or whatever, I'd say. But like realistically, breakout has it's one of those M's where it takes a while to get going and then it should learn very quickly. So like you should be able to at least get some sort of reasonable number of points. All right, well, it didn't help to go even lower on the data I'm using. Uh, maybe. More updates, right? I mean, you can't have arbitrarily little data, right? Yeah, so I mean, that doesn't scale it, like, better enough to be worth it, but... That's nutty. It is 3:26. I'm trying to think if there's anything I want to do today other than just run a hypersweep on this. Well, the problem I think kitting is that it doesn't scale like it's not this nice smooth scaling thing where you can use very little compute and a ton of data, or the other way around, because like that's the one thing I'm not happy with, really. So we'll see if this intersects or if this is actually just better the whole time. Tiny bit of sample reuse in a dumb way. Huge amount of sample reuse. It does seem actually like it's easier with less data for this thing, because the construction loss. Kind of messed up. If I do... Actually, here's a quick experiment. So if I just say that instead of 4 M's, we're going to have 64 M's. But I'm going to give you... Oh, wait, that's times 16, right? But I'm going to give you 2 million steps. It'd be the same thing, right? Actually, not bad. Actually, really not bad. That's actually a decent data scaling thing, right? We just got, yeah, we just got a better policy. We got a full solve out of that in less time by using more data. Does this work arbitrarily? Can I do D6? Can I do this? That's not bad. There's a little bit of stability shenanigans, it seems, if the data gets to be too quick. You see. Of course, I haven't mixed this with online RL yet. That's not going to do that much, is it? Be right back. Let me use the restroom. I didn't break this as well. Kind of curious. Oh, you know what it is? Okay, there's a 4x difference then. This and Dreamer. I missed a scheduler update. Thank you. It says I didn't. Alright, do you have the latest? It says there's no diff. No worries. Mm. Okay. I mean, it's a super noisy. You're getting real data though. Reconstruction loss is low. Same thing as puffer default, except I removed. Wait, what the heck? I removed actor critic. What? My guy. Like, there's no way. That's like a batshit, like, crazy network. That is, like, way, way too deep for RL. Alright. I will take a look. Oh, okay, that's a different story. Alright, well, we have a reconstruction loss that's reasonable. Mm-hmm. There's nothing fundamental here, right? This is just a harder problem. Hmm. Keeps looking like it's got it, but nah, it's just we're looking at noise. Until we're getting, like, consistently. Even 10 plus would be good. It's quite close, I'd say. B-norm somehow makes it worse. Alright. Chess RL might tackle it. The terminal reward and assign it across all moves within a game. What? What? No, you don't do that. No, you do. You do advantage estimation, right? I'd probably do, I'd probably do something where you give, like, the score of the pieces or whatever, and then anneal that reward down to just the win-loss reward over training. It's probably something like that would work. Yeah, that just, like, you need massive, massive scale for that, because, like, you can't do credit assignment with that. That's just, like, massive scale required to actually learn any form of credit assignment with that. Actually, so Jess, you want to know something funny with that? If you use reward of 1 for all moves, then literally all you're doing is you're running behavioral cloning on the winning side. So literally you're not even doing RL, you're just doing behavioral cloning. Isn't that funny? Math, it comes out identical. Alright, come on. We have something that solves Pong now, and we can't get anything on Breakout. Like, really? We have it running on Pong, and we can do pretty dang well on Pong in like 2 minutes with only 100,000 steps. And we've been not able to get anything better than a random on Breakout. Speaking of which, experiments are too bloody long. There, 2-minute Breakout experiment. Good. Could you have a system that caches or distills common state action patterns? Updates quickly with reward. And bias is the main policy. So depending on the environment, you're never going to see the same state twice. And fuzzy state action mapping is exactly what RL does. Breakout might just be harder to do with only 16 horizon. Last one. And then I think I'm just gonna launch a sweep and we'll call it early today. I'd like to have some time to recover today. Because basically I'm gonna go, I gotta go get myself a proper dinner. And I gotta do some recovery stuff because tomorrow morning, bright and early, will be a run as far as I possibly can. And we'll see how far that is. Last week was half marathon. Hoping for at least 15 miles this week. Ideally more, but we'll see how I'm feeling. No, downloading RuneScape means that there will be no future puffer versions. No RuneScape downloads allowed. Don't even tempt me. Exactly. Then you wouldn't have remotely enough data to cover that game. We just implement a RuneScape env. What do you think the idea was for a neural MMO? Like, yeah. Been there, done that. Alright. We'll let this sweep. We've got this experiment to watch. Right, we've got that experiment to watch, still running. We'll see whether this intersects and gets closer, or if this is actually, like, just the best thing ever. Wow. Well, those were the two big ones, right? RuneScape is substantially better for RL because of how the servers are implemented, though. It's like, done correctly, you should get at least like a 10x. It should take like a tenth of the compute, basically, for RS. Done correctly, then, for WoW. Alright, well, I mean, there's no use in me just sitting here for the sake of sitting here all day, right? I think I'm gonna go do some stuff. This is in, like... I think if we can get good hypers on Pong, and then if I can at least see some kind of initial result on Breakout, then that's enough for this stuff to be in, like, an okay spot, right? There is such a massive compute difference, though. Like, we literally solved Pong in 3 seconds with Puffer. And now it's taking, 2 minutes. That's kind of the main issue. The thing is, until I find, unless I find an alternative, though, this is basically the only thing I see that makes sense. Because, like, on policy RL is the only thing that actually works and is fast. And you want to be able to reuse samples. And the buffer from a world model lets you do that. And the buffer from the world model gives you, like, a more flexible way to reuse those samples as well. And then the only main, like, question is, can you have... Is there, like, is there a way you can parameterize a world model-based setup such that it is equal to on-pol RL if you give it enough data? Or can you just not do that? I guess that's the question. You can do vision-based M's, I suppose. It's just there's... Well, yeah, they would still be slower. Because, like, you're seeing the SPS here, but you're not seeing the learn SPS. Like, because this is not 1.9k steps per second trained. That's, like, real data samples. The amount of hallucinated samples is, like, way, way, way higher than that. Probably hundreds of millions. Yeah, because every time you're getting... What is this? 128... Every 128 samples that you get from real data, you're training on 32,000 hallucinated samples, right? So yeah, that's like a totally different... Well, very well then. Let me check the stream. Cool. Very few people watching on Saturday. I'm gonna go get some rest. I suggest you all do the same. If you're interested in my stuff generally, Puffer.ai for all the things. Start the GitHub. It's free. Helps me out a ton. You can follow me on Discord for more RL content. And other way around. You can follow me on Discord to get involved. and you can join the Discord to get involved. Follow me on X for more RL content. Yep, I need a night off. Gotcha. Holotopia, and when you build it. All right. Thank you, folks. I will see what I do for the rest of the day, but need some rest.